Hey there, guys. This is Christopher talking. Welcome back to my YouTube channel. Today, I'll be talking about my course assessment task 2. Here are the listing we're going to go through right now. Is the part 1 and part 2. For part 1, we're mainly focusing on the energy level diagrams and electron configurations. For part 2, we're going to be talking about the thermal chemistry. And for part 1, uh, before we start part 1, we need to know the 3 principles and laws in order for us to get better understanding about the concepts. So first thing comes first, the alphabet principle, which is to use to determine the electronic configuration of an atom or ions. And according to the alphabet principle, uh, electrons fill lower energy orbital first. On the right-hand side, it is the diagram that perfectly explains how alphabet principle works. So let's get a closer look. The arrows, which you can see in red, it's pointing towards the left side, which indicates where the direction is going. And those 1s, sp, d, f, those were orbitals, different orbitals. And as you can see, which one has the lowest energy levels? 1s, right? And then 2s comes next, 2p, and 3s. Realize the closer the orbital is, the closer you get, the closer you're next to the point of the arrow, the higher the energy levels you get. So that's basically how this works. For second one, we have the polar exclusion principle, which only 2 electrons can occupy the same orbitals. And the electrons that are presented in the same orbitals must have the opposite spins, or they should be anti-parallel. Here on the right-hand side, the diagram explains what the Pauli exclusion law is basically about. On the left-hand side is what you should do. Instead of writing on both sides, we should, actually the both spins, we should write in the opposite spins. And this is sometimes where people make a mistake during the test, and keeping an eye on that. Thirdly, we have the Hans rules, which every orbital in a subshell is singly occupied with a 1 electron before any one orbitals is doubly occupied. So here the diagram shows the electrons filled with the subshell singly before forming any pairs, and each electrons in a single occupied orbitals has the same spin. So here we need to make sure that we have all the electrons filled in every orbitals before moving on to the next, before moving on to the opposite spins. Here I'm gonna provide with the practice questions, just to see your understandings. So here is the sample questions, which is the TC, which has atomic numbers of 43, aka technetium. Here, I already did it for you. The energy level diagrams, it basically has 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d. So in 1s orbital, it can hold up to 2 electrons. In p orbitals, it can hold 1, 2, 4, 6. It can hold a maximum of 6 electrons. In d, it can hold up to 10 orbitals. So if you add them all together, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8. So basically, this is 10. And when you add them all together, it has a 43 atomic numbers. And that's the correct way of you drawing the energy level diagrams. And later it comes to the electron configurations, which is basically very similar to the energy level diagrams, but it's just slightly different in terms of the ordering. So the first thing comes first is always the 1s, 2s, 2p, 3s, 3d, 3p, and 3d, 4s, 4p, and 4d. Realize in every orbital here, it has the exponents. What does it stand for? Well, like I said before, for example, we have 1s2. What does the 2 stand for? It stands for how many electrons can it hold. And when you add them all the exponents all together, it should give you 43 electrons in total. And another way to write it, just in case if you make a mistake, is basically square bracket Kr 4p6 4d7. Realize the Kr is coming from the periodic table. And the 4p6 4d7 is where it ends up with. The last two orbitals tells you where the elements ends up with. So that's basically covers the entire part 1. Moving on to part 2, we're talking about the thermal chemistry. So the method I chose to use is the bond dissociation energies method, which is basically bond energy. Bond energy is the average energy needed to break all the chemical bonds between two types of the atoms in a molecule. On the right-hand side, you realize I provided with a picture, which it talks about the bond dissociation formula that you should be applying with. Delta H reaction equals to the sum of the delta H, also known as the bonds broken, subtract with the sum of the delta H, also known as the bonds formed. When you subtract the bonds broken with bonds formed, it should give you delta H reaction, which in this case is the bond dissociation energy method. Well, there's also the pros and cons for using this method. Let's talk about pros first. Well, I think among all the 3 formulas that I've been using, which includes bond dissociation energy method, His laws, and a calorimetry method, I'll frankly say that the bond dissociation energy method is the best one to use, and more straightforward and quite simple to use in terms of the calculation and steps. Because the bond dissociation energies and also the bond dissociation energies are useful in assessing the energetics of the chemical processes as well. But however, the bond energies are defined for gas phase reactants and products. This method does not account for the enthalpy change of the condensation to form liquids or solids. And so the results might be off systematically due to these differences. Also, in other words, their average values do not take into account a situation in which the bond strength is different from the average. Now we're going to one of those practice questions we have, where it's asking you the halogenation of a cyclopentane. Draw the structural diagrams of your products. Calculate the enthalpy change of the reaction using bond energy values. So we're given with a cyclopentane with a Cl2. What is the halogenation for that one? Simply, while we write this down, it's basically this how it looks like. The Cl is bonded with both C. After this step, what we need to do, the question is also asking the calculate the enthalpy change for this reaction. So we need to know the bond dissociation, average bond dissociation energy for each part of the structure. So here, notice C bonded with C, a single bond with a C. How many pairs there are? 1, 2, 3, 4. There are 4 pairs. So according to the average dissociation energy, value should be 350 multiplied by 4. How many pairs in C bond with hydrogens? But notice that the hydrogens do not appears here. It's invisible, but you should know how many carbons can it hold for hydrogens. It should be 4 of them. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pairs in C bonded with an H. How many C double bond with another C? There's apparently 1 pair. So 728 multiplied by 1. Cl bond with Cl, how many pairs? Of course, there's just only 1 pair. So 243 multiplied by 1. So we're done with the left side. Now we're moving on to the right side, which is the which we are applying for the halogenation rules. We get the C bonded with a C single bond with a C. How many pairs there are? There are 5 pairs. So 350 multiplied by 5. There's also C bond with an H. How many pairs there are? 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 pairs. So 410 multiplied by 8. Lastly, we have C bond with a Cl. How many there are? Only 2 pairs. So there are 330 multiplied by 2. After this step, we're not fully done yet. We need to apply for the formula. So we're given delta H reaction equals the delta H bond broken minus the delta H bond formed. In this case, we're using the right-hand side. We're added up the values on the right-hand side, subtract with the values on the left-hand side. And we're given 5,690 minus 5,651. What does it give us? 39 kilojoules per mole. Notice there's also the units. Don't forget that, otherwise you're gonna be losing marks during the test. Also, another question after this is that an endothermic or exothermic? If the energy is negative, this implies that the equation is exothermic, like exothermic. If the positive, that means the chemical equation is endothermic. So in this case, it's positive, therefore it's endothermic. That's basically covers the part 1 and part 2. Now we're going to the third section, which is the pitfalls. You know, many times there are things that students make a mistake on, and here I'm just gonna be talking about this. So there are a list down of things that I came across with, the pitfalls. When it comes to units, many times the students, including myself, would frequently forget to write the units. And at the end of the day, it should be incorrect. Because in chemistry, the units system requires it to be specific as possible. Let's just say if you wrote an answer without a unit, you would have definitely got this one wrong because you don't have a unit and you don't know where you're solving for. Next, we have the bond dissociation energy tables. Again, many students don't really understand how to use this table properly and get the wrong value, which we can call this a deadly mistake. And the purpose of which, well, we have to determine whether an overall reaction enthalpy, it's an endothermic or exothermic. So by using bond dissociate energy table, it helps us to determine whether it's an endothermic or exothermic. Otherwise, your equation, otherwise your values doesn't mean anything. And it's very useless when you not including the step. And lastly, we have the formulas. We suppose if you have all the values and calculations correct, but when it comes to formula, you don't know how to apply it. You don't know which ones to refer to. And that's where you lose marks on. In other words, what you should do is basically you need to avoid from this happening. And the purpose of the formula allows you to do all the work that led up to a formula to find out the answers. Let's just say if you have the answers, although you have the answers, but you don't have a formula, how are you going to apply it? How do you get the final answer? So that's basically the three parts that are going to be talking about for the pitfalls. And these three are very important and very essential. You should keep an eye on all these three mistakes that sometimes students may make a mistake during the test and something. And that's the end for part 1 and part 2. Thank you guys for watching. Please comment, like, and subscribe, and I will see you in the next video. Thank you.